Scientists have come up with self-healing, stretchable transistors, and circuits which will transform electronics and make a lot of things possible. This breakthrough paves the way for a new generation of smart devices that can bend, twist, and also repair themselves if damaged, making them ideal for long-term use in wearable and implantable technologies. The team behind this innovation, including researchers from South Korea's Sungkyunkwan University and the Institute for Basic Science, developed a method that allows these electronic components to be produced on a large scale, configured like building blocks, and used in highly personalized systems. And before we explain how it works, please hit the like and sub button to get more tech research news that will shape the future. And link to the original peer-reviewed research is in the description. Their inspiration came from how the skin stretches and also heals itself in the case of an injury. As such, the researchers found a way to give every layer of a transistor, whether it's the insulating layer, the semiconductor layer, or the electrodes, the ability to stretch and heal. This means the entire electronic device can survive the stresses of being worn on moving skin or implanted inside the human body where tissues are constantly shifting. Even after being stretched, bent, or physically damaged, these devices can restore both their shape and their electrical performance, much like how human skin naturally recovers after a cut. To make all of this work, the team relied on a carefully selected set of materials. First on the list was self-healing polymers, which allow the devices to recover from physical wear and tear. Then the second material was conductive nanomaterials, which ensure that electrical signals can still flow efficiently even after damage. And the third was organic semiconductors that add flexibility without sacrificing the transistor's speed or performance. They then blended these materials together in such a way that they separate vertically during the fabrication process, which helps prevent their performance from degrading under strain. This smart layering technique, combined with a scalable printing method, makes it possible to mass-produce the components on large sheets, which can then be cut and assembled like Lego blocks. Once the transistors are printed, they can be rearranged and combined in different ways to build specific types of circuits, from touch sensors, active display matrices, or systems for reading and responding to nerve signals. If one module wears out or stops working, it can be unplugged and replaced without throwing out the whole device. To be honest, that kind of modularity is rare in today's rigid electronics and could be interesting in personalized medicine and adaptive wearables. So far, initial tests have already shown promise. From the article, they say that devices built using this method were implanted in living animals and remained electrically stable over time. This opens the door to medical applications where long-term implants are required to monitor or stimulate organs like the brain, spinal cord, heart, or peripheral nerves. These systems could be used to treat neurological disorders, cardiac conditions, or chronic pain by recording biological signals and delivering precise stimulation in response, all in a closed-loop system that adjusts automatically based on the body's feedback. So at the moment, the researchers are now focused on boosting the electrical performance of their systems. They aim to increase the mobility of their semiconductors and improve the conductivity of their electrodes so the circuits can operate at higher speeds. This will be essential if these stretchable and self-healing devices are to handle the complex tasks required in next-generation neuroprosthetics or high-resolution brain-computer interfaces.